RKA, and I'm an idiot. In part 1 of My Little Universe, I was telling you everything I know about the beginning of this universe. In part 2, I want to talk about time. What is time? If you look it up in different dictionaries, you'll find different definitions. Oxford dictionaries, for instance, say it's the indefinite continued progress of existence and events in the past, present and future regarded as a whole. Well, that's a difficult one. Let's try Collins Dictionary. Time is what we measure in minutes, hours, days, and years. That's simpler. Let's try another one. Merriam-Webster says, time is the measured or measurable period during which an action, process, or condition exists or continues. Well, okay. It's about time we ask a real expert. Hey Albert, what is time? Zeit ist das, was man an der Uhr abliest. Okay, I understand. So, in order to know what time is, we need a clock. But what is a clock? Let's go back to the library. Oxford dictionaries say it's a mechanical or electrical device for measuring time, indicating hours, minutes, and sometimes seconds by hands on a round dial or by displayed figures. That sounds fair enough. Do we all agree on this definition? Well, Merriam-Webster makes a point that you have to distinguish between a watch and a clock. Does it really take a mechanical or electrical device to measure time? I mean, time was measured long before clocks and watches were invented, just by observing the sun and the moon and the stars. Have a look at this picture. Can you guess which one of the two persons is older? I bet you can. The lady on the left is probably somewhere between 25 and 30, and the little young person on the right is probably a few months old. No watches, no clock, not even stars, just biology. So, apart from mechanical or electrical devices to measure time, and apart from astronomy, there are also biological methods of measuring time, and they are extremely reliable. The chances of the person on the right being older than the person on the left on the previous picture are 0.0%. Trouble is, the biological methods are not nearly as precise as the technological ones. Hey, what about a little experiment? Have a look at these two pictures. These steaks look fairly fresh and delicious. Now, rather than putting them on the grill right away, I suggest we keep them for 4 weeks. The one on the left we put in a freezer, and the one on the right we'll keep in the bright sun. Let's see what happens after 4 weeks. After a thawing period in the fridge, the steak on the left looks pretty much like it looked 4 weeks ago. But what about the steak on the right? Believe me, you don't want to know. So, if you keep the steak in the freezer during the 4 weeks, it doesn't really age. If you keep it outside, it's rotten. Isn't that interesting? I mean, Doesn't that imply that the steak in the freezer ages much slower than the steak outside? Doesn't that imply that time for the steak inside the freezer is moving much slower than time for the steak outside? Of course, you might argue that if you put a clock inside the freezer and a clock right next to the steak outside, both clocks will agree on the amount of time that has passed. But these clocks measure the time of the clocks, not of the meat. So, what is time? Let's start out with what time is not. In my little universe, time is not a universal fourth dimension. It's not a continuum. It's not self-contained, independent, and autonomous. In my little universe, there is no general time moving around you from the past to the present to the future. Instead, you move through my little universe and you are accompanied by your time. You're surrounded by it like a halo. Wherever you go, you take your time with you. Time is a property of matter. Every piece of matter has its own time. But time only affects macroscopic parts of matter. They follow the laws of relativity. The microscopic particles like quarks are not affected by time. They follow the laws of quantum mechanics. Time. Oops, it's time to go. Bye-bye.